In this problem, a student runs a comb through her hair and the comb becomes negative. What does this tell us if the comb's becoming negative? That means electrons are going into the comb and they must be coming from the hair. So therefore, electrons from her hair go into the comb. Number 2 says that we have a total charge of 100 coulombs going by a fixed point every 500 seconds. What's the current? Well, we can use I equals Q over T, and we know that the charge is 100 coulombs, and we know that the time is 500 seconds, so we just divide those two to get 0.2 amps. In this question, it says an electric field, which we know the electric field would be down in this case, between two opposite plates, which particle will be deflected towards the positive plate as it enters? So we did this in the lesson. It's going to curve up like that towards the positive plate. And what particle would do that? Well, that would be a negative particle, and the negative particle could be an electron. This one's kind of tricky. So we've got this negative rod, and we've got two different particles that are hanging here. Now, the one case we have repulsion, and the other we have attraction. We can only get repulsion when we have the same sign. So we know that this has to be minus. Now, attraction can occur when we have either the opposite sign or when it's neutral. So therefore, if we look at the choices here, sphere R must be negative and sphere S must be positive or neutral. Number 5. So in this one, it's not really an electricity question, but I wanted you to see how to do this so you didn't get tricked. 60 watts. So that's telling us about power. And we also have time. And they want to know what it is to lift this object. So we can go straight from P equals W over T and say 60 watts is equal to the energy in a time of 60 seconds. So that means our work or our energy is 3,600 joules. Well, how far is that going to lift this 10 Newton object? Well, that means that that is going to turn into PEG. And we know PEG is mgh. So we have 3,600 joules is equal to mg as our weight, so that's 10 newtons, times height, and that height comes out to 360 meters. There's a lot going on in this problem, and it sounds kind of hard, but in reality, this problem isn't that bad. So they give us some information. They give us the electric field, and they give us the mass of this oil drop that's levitating in here. So the first question is, calculate the magnitude of the gravitational force acting on the oil droplet. Well, what's the gravitational force on the oil droplet? That's just mg. So we have Fg equals mg. So that's going to be the mass, which is 1.96 times 10 to the minus 15th kilograms, just multiplied by 9.8 meters per second squared. So what's the result of that? That's going to be the weight of the drop, which is 1.9 times 10 to the minus 14th newtons. So the next part says, determine the magnitude of the upward electrical force acting on the drop suspended motionless between the plates. So if this is motionless, that means the net force is 0. So the force down due to gravity has to be equal to the force of the electric field up. So therefore, what's the answer? The answer is the same as this. Fe is equal to the force of gravity from part 6. And last, it says calculate the net electric charge on the oil droplet. Well, because we know the force, we can get the charge from E equals F over Q. They gave us the electric field, that was 4 times 10 to the 4th newtons per coulomb, and that's equal to the force, which was the 1.9, I rounded it off, it was 1.92 times 10 to the minus 14th newtons over Q. So Q comes out to 4.8 times 10 to the minus 19th coulombs. In this one, we have a charged particle in an electric field, and they give us the electric field, and they also give us the force and what's the charge. So we can just do the formula we've done before, E equals F over Q, and we have the electric field, 2 times 10 to the third newtons per coulomb, is equal to the force, which is 3 times 10 to the minus third newtons, over the charge Q. And just do the math on that, and you get 1.5 times 10 to the minus 6th coulombs. The last question here, it says the work per unit charge. Well, what is work per unit charge? Well, we know that's V, that's the voltage. And what's another word for voltage? Potential difference.